Hello everyone. In this podcast we're going to talk about activated carriers. And in the previous podcast we talked about certain kinds of coupled reactions. We talked about how a favorable reaction here going from A to B could occur, and that the energy produced from here, because this is a negative delta G0, and the energy produced from this could drive this unfavorable reaction going from C to D. It had a positive delta G0. So the question is, which I'm sure has been bugging you and keeping you up, is how does that energy move from here to here? How do we transfer that energy? And we transfer that energy using these activated carriers. So we can think of often these reactions over here with the favorable reactions as catabolic pathways. Breaking up food into smaller components. And then we need to take those smaller components and build new macromolecules. And these would be anabolic, unfavorable reactions typically. In order for this to happen, we need to transfer the energy from this reaction to these reactions. And we, again, just to repeat it, we use these activated carriers. ATP. Let's talk about ATP. ATP is the most widely used activated carrier. We can put ATP up here in this picture and ADP down here. Going from ADP to ATP, this is an energetically unfavorable reaction. It has a positive delta G0. But even though it has this positive delta G, this can be moved forward because of ultimately the sun and food that drive this reaction. And these reactions, through various steps, will create this ATP. The ATP itself is an activated carrier. It is fairly easily converted back to ADP. It has a negative delta G, 0. But its role is to be this carrier, as I said. And as that carrier, it uses that energy. So the energy from ATP is used for cellular work. I don't have room to show it here, but this ATP that's used for cellular work is coupled with unfavorable reactions. So certain reactions that are unfavorable become favorable because of this activated carrier of ATP. So next I want to talk about these two activated carriers that are pretty important in the cell. NADH and NADPH. When they transfer their energy, they become oxidized to NAD plus and NADP plus. Just like with ATP, these are coupled with unfavorable reactions. Both of them are. The energy that is carried in these two molecules is transferred to unfavorable reaction. Okay, I want to talk a little bit more about NADH and NADPH. The only difference between them is the difference of a phosphate group on NADPH. So it really doesn't change their overall structure much, but it does change their shape. So their shape is different. And shape is very important because that means they will fit into different enzymes. Because of this shape, as I said, they'll bind different enzymes. And, well, let me just write that down. So why do we need this difference? Well, it helps kind of separate out some of the powers that they have. So NADPH is typically found in anabolic reactions, synthesis reactions. NADH is often found coupled with catabolic reactions. And these catabolic reactions will often generate, and I would just put an up arrow for generate, ATP. Okay, that's all I want to say about NADH and NADPH for right now. There's another really important activated carrier that you just need to know, and I'll write it down here, but it's AcetylCoA. We'll talk about that later in the semester, but for now, I just want you to know that this is an activated carrier. Okay, that ends what I want to say on these 3 podcasts. And so I want to end with a quick summary. In the first podcast, I talked about enzymes. And in talking about enzymes, we talked about their role in metabolic pathways. And we talked about how they function when they bind substrates and how they will help pressure them in forming certain kinds of products. And we talked about how they reduce the energy of activation so that spontaneous reactions are more likely to occur. And remember, we also talked about Vmax and how Vmax was a concentration of substrate where all of the active sites were filled. We also talked about Km and how the Km is the concentration of substrate that half of the active sites are filled, so half of Vmax. And these are important terms when we're starting to compare enzyme. We then spent quite a bit of time talking about delta G, delta G0, equilibrium constants, and how we use these to define reactions. And then we ended with that talking about how reactions are coupled so that we can, how favorable reactions can help unfavorable reactions move forward. And then we closed with activated carriers, talking about how the energy created from these reactions up here from step 2 is used to carry that energy to unfavorable reactions. Okay, that is all I have for these podcasts. If you have any questions at all, please make sure you come see me. If not, I'll talk to you later. Bye.